Hi, I'm Ms. Vuong. Today we're going to look at direct proportion. Direct proportion. Out of these four images, which would you say have direct proportion? Well, this one and that one over there. Direct proportion is when the relationship between two variables, let's say x and y in this case, have the following three characteristics. Firstly, as x increases, so does y. We can describe this as y equals kx. And k is called the constant of proportion. And then the second thing that things that have direct proportion have in common is they go through x is 0 and y is 0. See the graph over there? It goes through 0, 0, as well as that one over there, 0, 0. And the third thing is the graph of the relationship. So the graph of the relationship is a straight line passing through the origin. Kind of sounds the same, that point. That point is kind of inside that point. So anyway, so these are the three points to describe if something is directly proportional to another thing. Let's look at an example. State whether the following relationships show direct proportion. First, check the ratio for each pair. So we have x values here and y values. And we can look and see if there's any patterns. We clearly see that there's a pattern here and each of our x values can multiply to give us the y value. So let's have a look at the ratio, y over x, or 4 over 1, that's 4, 12 over 3, that's 4, etc, etc. We can clearly see that there is a constant ratio, or in other words, the ratio y over x is constant. Therefore, we describe y is directly proportional to x. And we write the symbol like so. The directly proportional symbol is like that. It looks a little bit like a little fish. So that reads y is directly proportional to x. Example 2, state whether the following relationships show direct proportion against the same pattern and by first finding the ratio. So again, let's see if you can figure out what the ratio is. So 0 over 0 cannot tell us much, but 2.5 over 1 does. And we can see that all of these are 2.5. The ratio of y over x is 2.5. And it's always the same. So it has a constant ratio and it goes through 0, 0. If you're wondering whether the previous example went through 0, 0, you can extrapolate backwards and you can see that it also does go through 0, 0. So the x values and y values increase by a constant amount, which is a multiple of 2.5. So the relationship is linear. So y is said to be proportional to x in this example as well. So these are the three statements we covered at the start. Does it go through 0, 0? Yes. Is the x value and the y value increasing at a constant amount? Yes. Is the relationship linear? Yes. Therefore, y is directly proportional to x. Here's a graph, example 3. Do you think this one is directly proportional? As we can see, as the number of cans increase, so does the cost. And when the cans is 0, the cost is also 0. And the can values and the cost value increase by a constant amount. It's a straight line. So the relationship is linear. So we say, yes, the cost of the cans is directly proportional to the number of cans. Example 4. What about this one? If you're traveling that many miles and it's costing you that much petrol, is it directly proportional? Well, as the mile increases, so does the cost, but when the miles is 0, the cost is not 0. So we have found one of the statements. Well, when the miles values and the cost value increase, they do increase by a constant amount. But again, it does not cross 0, 0, so it is not directly proportional. So even though it has some attributes to being directly proportional, as long as one of the attributes fails, we say that it is not directly proportional. Example 5. What about this one? It is clear that it's not linear. Let's look at what statements from our description it fails. As x increases, we can see that y decreases. So that's not true. Does it go through 0, 0? No. Does the x value and y value increase at a constant amount? No, and there's no linear relationship. This is a curve. So y is not directly proportional to x. You do not need to write all this. You just need to write this statement here. Okay, thank you for watching, and I'll see you next time. Bye.